But good afternoon, everyone. And thank you for joining. If you are on the live stream or watching this on YouTube post event, I hope you're having a good day and staying safe. Today, I am joined with George from Kochi. Is that how I pronounce it?
It's called Kochi.
Kochi. Okay.
Yep.
I mispronounced that one. I hope that's not something accidentally offensive in.
No way.
And George is a practice lead for
UST.
UST.
Yep.
And do you mind telling us a bit about yourself before we jump into today's
Sure.
session?
Sure, sir. Sure, Sam. So thank you for the opportunity in the first place. So I'll give a short background of what I've been doing in the last, I would say, last 2 decades. Okay. So I'm based out of India. I live in a city called Kochi. So there are two cities by the same name. There's a city by the name Kochi even in Japan. So
Ah,
this is in the southernmost part of India. It's a bit mostly a coastal town or a coastal city. So, in fact, did my engineering in the city around 21 years ago. I actually passed out my engineering. I had a degree in computer science, and I wanted to be a programmer. I never had any intentions to get into the software testing stream. And during those times, during the early 2000 time frame, in India, we did not have software testing as a career stream. Only very few companies, mostly companies like the ISRO, which is basically the Indian version of NASA. Those companies or organizations actually had a QA team, and they were mostly doing white box or device driver kind of testing, and there was minimal amount of black box testing that was happening. So software testing was never a stream. So I did a lot of what do you call additional courses up to my engineering around programming. So I actually I took certifications on the Microsoft stack, primarily on Visual Basic, Microsoft Transaction Server, SQL Server, and all those tool sets. And then I actually got a job in a services organization by the name Caravel in Bangalore. So it was basically a smaller organization. We were mostly doing projects for some local clients as well as some Canadian customers. And I was actually taken there as an ASP developer. There was no .NET that time. It was mostly ASP and Visual Basic. So I was actually taken as an ASP developer. And unfortunately, I would say rather fortunately, the client actually decided to scrap the project that I was working on. And I was actually given an opportunity to move into the testing stream. So this company had around 50 developers working on multiple customers. And one of the major groups that they had was a product development group which was focused around developing a product around e-learning, and they were developing the first version of the product. So they were really looking out for someone who can actually help them to bring up the quality of the product before they actually release version one. And I was actually given that opportunity to test an e-learning product. So I had no background on testing. We had the only source of information that I had was maybe Yahoo and Google, I would say, in order to search for information. Even test case templates and all of those were very new to me because my only background around software testing was one paper that we had for engineering, which was called software engineering. So that also did not cover a lot of great things about testing. So that is a good opportunity. So I was the first tester. Had a very good time testing the product, and over a period of time, the company is also pretty happy, as well as the end customers are also happy. And as a result of that, that company decided to outsource the testing of few more products that they were having around the e-learning side. So in a span of 2 years and 7 months, we had an 8-member testing group, and we were testing around 3 to 4 products. So even though I was working in a services organization, the experience that I gained there, Sam, was mostly around product testing, which is of great use. And one good thing that happened during that time frame was that the company decided to go with the ISO certification, and there were a lot of processes that were being set up during that time, which also helped me to understand the processes from what do you call an ISO perspective, like what were important for the organization. Like we had set up templates for different aspects of software testing and things like that. So that's a good experience. And from then, I decided to move on to a product development company by the name Mysis, and they had multiple businesses. They were primarily into financial services, banking, and the group that I was working out was basically healthcare group, which had around 8 to 10 different products. So I was actually recruited there as a quality control analyst around a pathology product. I was actually working for a pathology product, and this is one place where I understood the need for having domain experience. So even though we were a testing group, we actually had a mix of software test engineers and product SMEs or domain SMEs. So we had doctors, we had pathologists, we had blood bank specialists, all of us working as part of the quality control group there. And this experience was really good. And I got mentored by a lot of what I call domain experts within the organization. And that point of time, the company actually was running a dedicated automation group. This was way back in 2003, which was focused around Windrunner, couple of custom tools, Test Director, and other tool sets. So, and the India team was being set up. So we were given an opportunity to attend an internal assessment around these tools. So we had to actually mug up Windrunner and all of those tools on our own. And then we got an opportunity. I got an opportunity to move to the automation group. So that is one of the best maybe things that happened to me. I worked in this group for close to 4.5 years. We automated around, I would say, around 7 to 8 different products, starting from client-server applications, and then we moved on to .NET. The client-server application actually were converted into .NET. At that point of time, we moved on to QTP, which is now called UFT. And this company actually had around, what do you say, for one single product, which was the laboratory product, we had around 4,800 automation scripts, which was basically one of the largest automation packs that I've seen during that time frame. And the entire regression process which was done through a manual mode earlier used to take around 2.5 months of time with around 10, 15 testers. And that was actually shrink to almost like 3.5 days, which is one of the first value that I saw around test automation. And the stability of scripts was also very high. We never used to have false failure rates of more than 1%. There was constant maintenance that were done to the automation assets, and it was one of the best automation teams that I've ever worked on. From then on, I actually moved on. I had a very short stint from after I left the Mises in 2008. I moved on to SAP, which was basically a product development company again, mostly on the CRM stream. But my job there was mostly related to test environment management. I was actually managing a group of testers or engineers who were actually managing test environments, mostly for the Microsoft CRM product. And from there, I actually had to come down to my hometown or my home state. So what I did was that time I started looking out for jobs, and that's how I actually landed up in USD. And I started working on the delivery side, mostly around retail customers. So I was primarily focused around e-commerce, point of sale, and other areas. And I closely worked for around 4 to 5 years in this particular domain. And then at that point of time, I realized that I was spending a lot of time on around management activities. I was mostly doing a role of a test manager or a program test manager. And I did not want to spend a lot of time around financial management, team management. I had a very large team of 200 plus testers, which was actually eating up a lot of my time. I was not actually getting enough time to do things that I like, which was basically test solutioning, actual testing, and activities like test automation. So I decided to move from a test management stream to a test architecture stream. And I was actually part-time in the COE, but after a few months, I decided to become a full-time member of the Center of Excellence group within USD. From then onwards, I started working on different activities, mostly around working with customers and understanding their pain points, defining solutions, doing test maturity assessments, taking part in test transformation planning and implementation. There are a lot of activities that I got involved. And over a period of time, the last, I would say 3 years ago, I got matured into a practice leader kind of a role, which is basically a global role. And I manage 3 different functions. So one is basically a service demand function, which is mostly around working with customers around problem solving, solution development, doing RFPs, presenting the company's capabilities to customers. There's a service innovation group, which was basically a group which is focused around developing a platform for testing, which is called NoScript. We started this journey around 3 years ago. So that's something that I would actually put that as one of the key milestones in my entire career. And then the third activity that I do on a day-to-day basis, supporting customer accounts or customer teams who are actually engaged in delivery, helping them solve some of the risk and implement some of the best practices around testing. These are some of the activities that I get involved. So that has been my life within UST. I spent a lot of time on learning. I focus on learning new technologies. I would say last 2 to 3 years, I've spent time on learning things like DevSecOps, RPA, cloud, and other technology. Because what I see is like there's a lot of influence on technology and testing, and it's very important to keep myself updated on what's happening around the technology stream as well. That's a very brief introduction, Sam, about myself.
Well, you're talking about keeping skills up to date. What are
Yep.
you the most excited to learn about at the moment?
Yep. Maybe I would say maybe there are 3 or 4 streams that I started focusing on. Maybe to take a and look at what I did 10 years back. I wanted to actually get into the security stream. I started learning courses around, what do you say, cyber security, ethical hacking, and other stuff a couple of years ago, but I was not very successful. And I again wanted to take a second attempt at it. And last year, what I did was I started taking up a course around DevSecOps, which I found very interesting due to two reasons. One is to learn DevSecOps. One thing that I realized is you should be at least knowing the basics of DevOps to a very good extent. So I have to actually learn tools like Git, GitHub, GitLab, and even I have to actually look at Docker to a very good extent. So you should know how to actually run a Docker, create a Docker file, and things like that. So it took almost like 6 to 8 weeks for me to learn the basics, and then it took around 2 weeks, 2 months, in fact, to learn the security aspects of it. So DevSecOps is one area because I actually wanted to get into that field long back. So that's one area that excited me. Other than that, even DevOps is one area where I thought there are a lot of good things that I should be learning. It's very aligned to testing. It's mostly confined to continuous testing, but there are a lot of other practices that you can implement. And the third stream, Sam, which I found very relevant for testing is RPA. So there are a lot of use cases that I saw where RPA can be applied, and it is important for testers to actually take a look at the basics of RPA, or at least learn one RPA tool. Because there might be a lot of activities that you can automate in your test lifecycle using an RPA tool. And I've also found scenarios where, or use cases where the customer has already invested in an RPA tool, and it might make sense to actually reuse the tool rather than going with the commercial version of a test automation tool. That's the third area that I found very interesting. And then if you want to do maybe tool development, if you want to develop small solutions, I found Microsoft Power Apps also to be one of the skills that I liked learning, because instead of spending what you call hours together developing applications by writing code, if we are not having enough time, or if you have a very small problem to solve, it might make sense to learn a no code or low code platform like Power Apps or maybe Google Apps. So these are some of the areas where I found interest, and I have even now I spend a lot of time every week in order to brush up my skills.
For anyone who is unaware of, RPA stands for Robotic Process Automation.
That's correct. That's correct. So maybe the testing version of it can be a scriptless tool, I would say, because most of the RPA tools you don't actually have to write a lot of code. So it may be even if you look at some of these tools like maybe Tricentis Tosca, what I see now is like even though they are scriptless tools, there are also RPA versions available. In the sense like these tools can be used even for RPA. Same applies with UiPath, which is again one of the most popular tools around RPA. Now they have a test version also. There is a test version of our UiPath, which means like it's a UiPath that is very specifically focused around software test automation. So there are a lot of what I call similarities that you can find between a scriptless tool and an RPA tool. I would say that they are maybe like 60 to 70% similar.
Yeah, I've just got a blog up for anyone on my screen at the moment on comparing the differences, and UiPath is mentioned
Yep.
as a top tool, and there's a bunch of tools that fall under that umbrella.
Yep.
I hear a lot of Indian-based testers and developers talk about RPA tools. I
Yep.
don't tend to see it locally as much, but there seems
Yep.
to be a decently big market for
That's
those
true.
types of tools.
That's true.
Yeah. So today we're going to be talking about the cost of testing, and we've got a couple of questions that we're going to go through. We're not exactly doing, live pair testing on a product, but we're just going to talk about our testing processes and hopefully get up to speed with how we can justify the cost of testing. So is testing considered a cost center?
Yep, it has been the case since last, I would say, since the time that I started working in this stream. So, software testing has been considered as a what you call overhead in many organizations, and many organizations even previously when we actually had independent testing groups or what we call as independent verification validation groups or TCOEs or test factories, that was the case because there are questions around the investment around testing, primarily because you are not actually seeing a software product being developed. You are only seeing a better quality product coming out. And many times I would blame the test organizations or the people who are leading test organizations. They were not very smart enough to actually showcase the value of testing to the stakeholders as well as to the business team. So, and after we actually moved away from a waterfall methodology to agile, there is no ownership around testing. You rarely see roles like head of testing or maybe a director for testing kind of roles in most of the organizations, because many test organizations have merged their testing group with the app development group. So there has been not much of what do you say ownership or dedicated people who are actually focused around testing. So the questions have actually increased now, and many of them who do not have a good background on testing feels that testing doesn't add a lot of value to the entire what do you call value chain, and is also seen, and testing is also seen as an inhibitor in many organizations, because they feel that the software releases to production are actually slowed down because of what do you call manual testing processes or practices, or maybe application of low levels of automation. Things like that have actually contributed to that kind of feeling, but that's not true. There are many ways in which you can actually bring up, we can actually show the value of testing to a stakeholder or to someone in the business. And that is something that we're going to cover in today's session as well.
Okay. So, if someone's asking you about the value of testing, where is a good starting point in explaining that?
Okay. Yeah. So maybe the best thing to do is basically look at what actually contributes towards the cost of testing. Okay. So from my experience, when I look at the testing cost, there are maybe 3 or 4 things that adds up to the cost, and there are certain. So one is basically the items that are contributing towards the testing cost, and second thing that we need to look at is why are some of these, what are some of the challenges that exist within testing, and how is it actually adding up to the overall cost. So maybe if you look at the 4 factors, important factors that adds up to the testing cost, the first one is around resources. So any kind of person or a person whom we are employing to do software testing, whether it is automated testing or whether it is test support activity or test management, that's basically a cost or a cost of a resource. You need to pay him salary. So that salary and the entire expense is actually considered as a resource cost. And then if you want to do any kind of automation, or if you want to do any kind of test management or defect management, one should actually invest in tools. And if you're investing in what do you say, a commercial tool, definitely there will be a cost associated with it, which is basically called a testing tool cost. And then you need environments to run your functional test as well as your non-functional test. So there's a cost that is associated with test environments as well. So either you invest on an on-prem kind of an environment, or you basically use the cloud environment for testing. So test environment is one cost. And there's one fourth element which is very important, is the, the, the phase at which we are identifying defects. So that actually adds up to the overall cost of development, and that includes even the testing cost, which is basically the phase at which defects are identified also adds up to the overall testing cost. That's a fourth parameter which is often actually ignored. And now, if you look at the other parameters around challenges, why the testing cost is high, there are multiple. Maybe you can actually put together maybe 10 or 12 different, what do you say, reasons why the cost is high. So maybe if you look at maybe one of the important factors that is actually contributing towards the cost increase in the cost around resources is basically the skill set that you need. For example, if you're dealing with an application that is hosted in the cloud, and if you want someone to actually do some kind of testing around the new application that has been put into the cloud, you need someone with a good technical background, and technical resources comes with a cost. And now most of the organizations have actually gone towards a model where you're actually deploying software development engineers for tests, or what you call T-shaped resources or SDITs. And SDITs are actually what do you call very costly, and they're very you hardly find good SDITs in the market. There's a lot of demand for SDITs. So the overall resource cost is actually increased, which is actually one reason why the testing cost has actually gone up. And there are some technical challenges also that is actually leading to the cost of testing. One is primarily the amount of testing that is done by developers are still low. So I don't actually see a big jump in the development test coverage, even though the unit testing or the development integration testing kind of coverage is still low, primarily because you're working on a 2 to 3 week kind of sprint, and developers don't get enough time in order to understand the user stories, to prepare the design and then code and then do their testing. So testing is actually compromised. So, and primarily the amount of time that they need to spend is around designing unit test cases or designing development integration kind of tests, which is for which they don't actually really find time. Nor there is not many organizations are actually using an automated approach for designing tests. That's one reason. The second reason, or the third reason, is basically on the testing tools. There has not been an increase on the testing tool cost. In fact, what has happened is many organizations have gone ahead with low cost tools. So instead of using a quality center, many organizations have decided to use a Jira with Sapphire, or what you call low-cost tool implementation is one option. And then many organizations are open for open source as well. So the testing tool cost has not gone up significantly. And on the test environment, what has happened is there are still many organizations who are not very open towards the cloud strategy. So what has happened is they continue to use on-prem environments. They're very costly when it comes to both functional as well as non-functional testing. And then the manual mode of test execution is still there. There are maybe a handful of organizations, mostly Fortune 100 or maybe 200 kind of organizations have achieved maybe 80 or 90% of automation coverage. The automation level continues to be low, even though there has been some improvements in the last couple of years. So the manual mode of test execution still continues. And you really don't know whether you're actually writing too many tests or you're writing too less of tests, because everything is actually a person dependent kind of approach when it comes to test design. There are very few organizations that I've seen where there is a structured approach for test design, where a model based testing approach or a classification tree approach is basically used in order to design tests. That's one problem. And then if you want to actually look at testing, one need to actually look at the current process. Even though there are a lot of tools like value stream maps, there are not many organizations or testing groups who are actually focused on around bringing continuous improvement. So you basically you should actually look at how is that I can optimize my testing by bringing in more practice. So there's a lack of what you call continuous improvement. And then the last point that I would like to highlight is where you're actually finding your defects. So if you're actually finding defects towards the fag end of your release, that adds up to the overall cost, including development. So the late identification of defects is again a problem. Even in an agile mode of working, what I see is like there are a lot of defects that are uncovered towards the product demo or towards the release testing kind of phase rather than the sprint testing. And there was also not much of focus around preventing defects from happening. So why testing is there in the first place is because someone is actually inducing defects, or the practices that have been that have been deployed in order to arrest defects in the origination phase is weak enough. That's the reason why we actually have a dedicated person testing the product as well as identifying defects. So there's not much of focus that has been put in order to prevent defects in the first place. So that's also one area that's actually contributing towards the higher testing cost. So this is my high level views, Sam, around why what is the cost of testing and why is it so high?
There is definitely a lot of content there that we could potentially dive deeper into. And,
Yep.
we're already 25 minutes into this
Yep.
interview, so I don't think we're going to quite have enough time
Yep.
to cover everything
Yep.
today. But in terms of all that big list of challenges you focused, what's usually the first thing that people focus on, or what's likely to be the first step to bring the most amount of value in a short time?
Yep. So I would say the first area of focus for any organization would be to actually remove some of the manual testing activities that are happening. So that is one focus area. But there are but I don't see a structured approach in many cases on how this is done. So the focus is always many of the organizations two things. One is everyone wants to show up that there's a lot of automation happening in the organization or in the department. So there's a lot of focus around automating maybe user interface kind of test cases, mostly regression test cases. So test automation is definitely, or changing the manual mode of testing is definitely an area which can bring in a lot of value in terms of speed as well as in case of cost reduction. But it should be done in a very structured manner, and it should not be just limited to regression testing alone. You can actually apply test automation for many tasks. It can be applied to maybe automate some of the reviews that are happening around deliverables. So I've seen solutions that can actually maybe help review a test plan that is actually prepared in the Word format using maybe NLP. It can be in terms of reducing your defect triage time by bringing in something like a classification of defects or assigning auto assigning of defects to developers. So there are a lot of activities that can be automated. It should not be just limited to regression testing alone, but test automation should be the first activity that should be focused rather than just limiting it to regression. One should actually look at automating the entire life cycle of testing, starting from maybe a sprint planning to maybe to the production monitoring phase.
Yeah. My preference is to. I don't think it's usually a great idea to. A lot of people start with automation at the GUI layer, and that's probably one of the most places that's subject to the most amount of change. And
Yep.
also, it's a really hard engineering problem to automate the GUI because
Yep.
you have to introduce waits and sleeps, and
Yep.
to build non-flaky tests is a hard problem.
That's right.
And that is in itself is also a very expensive testing problem.
Yep.
For that one to be your first step into automation, I tend to think that it doesn't add that much value
Yep.
focusing
That's correct.
on that point
Yep.
first.
That's correct. So even now, and the reason is basically UI automation is very fancy. You see what's happening. So everyone wants to actually run tests on multiple browsers, show the value in that way. That's a problem. But definitely API tests are faster to automate, faster to run, easier to maintain. The first focus should be on API tests. And that's something that you can easily do within a sprint. You don't require a lot of technical knowledge also to do that. So
Yeah.
that's definitely, and in today's world, almost every application that is being built newly is mostly a microservices based application where you can actually spend what you call, it's worth spending time on automating those tests because that is actually going to give a lot of value. Once before you even build your UI, you can actually make complete at least 30 to 40% of your test. So
And
that's
yeah,
the focus.
you don't need fancy tools to be able to do API
Yep.
testing either.
Yes.
If you know a little bit of bash scripting or a little bit
Yep.
of command line, you can hit any API with a simple curl command and then write a little bash script that can layer on top of that. But then
Yep.
tools like Postman are really easy to start when it comes
That's
to
correct.
API testing if you want a GUI. But
Yep.
I think you'll impress all of your friends if you do everything from the command line. You just look like a real hacker boss if you are,
Yeah.
sitting there doing everything from the command line.
That's true.
Okay. So the next question is, how can we make the cost of testing more transparent?
Okay. So that's a very important, if you want to actually show the value of test organization or a testing team, or even a tester, a role of a tester in an organization, if you want to show that value to someone in the business team or someone in the IT stream itself, there are a lot of ways in which you can actually do that. So one is basically, one can actually look at maybe there are a lot of metrics that we collect. For example, even doing the waterfall era or in the agile world, we collect a lot of metrics. But very rarely, what we do is we basically use metrics to show the value of testing. There are two things that I've done in my in my career to demonstrate the value of testing to customers as well as some of the customer stakeholders. So one is basically IT based metrics that can actually show something like maybe the savings that have actually derived by preventing defects from happening in production. I can also look at things like availability of applications in production. And then if you look at the DevOps world, there are a lot of DORA metrics, what you call as DORA metrics, which can actually show maybe how that a testing team is adding value to the deployment. For example, deployment frequency is one of the DevOps metrics. And typically, organizations want to actually make releases in a year, in every hour, or maybe they want to actually get to a state where they can actually do maybe daily releases. So deployment frequency is one of the metrics that can actually show the value of testing, along with the lead time for change, which is another metric which can actually showcase like how fast am I actually putting builds into production after the developer is actually committing the changes. So lead time for changes and deployment frequency are two good KPIs or metrics that can actually demonstrate the speed at which testing is happening, and this can be actually one lever that you can use along with the ones that I mentioned around application availability as well as defect prevention cost. And then you also need to look at the quality of testing that is happening. So maybe from a DevOps standpoint, something like a change failure rate, which should be ideally 0%. So change failure rates is basically the amount of builds that I've actually taken back from production. So I deploy something to production, I'm actually restoring the old version because the current version is buggy or it's not working. So change failure rate should be ideally 0, but in the real world, it's somewhere between, I would say, it can be anywhere between 0 to 15% in many organizations, which do not have enough maturity. And then once you actually deploy these builds to production, it's also important that once it fails, you should be able to restore services. So your time to restore service is also one KPI that you should be using in order to, make sure that you're able to recover from failures that are happening in production. That's mostly the IT side of it. So and there's one more element that you can actually do, which you're actually dealing with someone in the business side. It might make more sense to actually talk about how much of improvement am I bringing into the productivity of associates, assuming that I'm actually doing an internal application and I'm responsible for testing the internal application. It might make sense to actually bring in metrics like productivity improvement of staff because an application was actually deployed, or if I'm actually dealing with something that's external facing that contributes to revenue, I should be also be able to showcase things like how much of revenue has been increased since the application actually had a better quality. So we should be able to quantify the value that is coming out from testing, both from an IT standpoint as well as from a business standpoint. But what
Yeah.
I would like to highlight is maybe I can show you two examples. Maybe I can actually showcase how the defect prevention cost savings can be demonstrated, as well as I can also show a small example of the application availability, how these two KPIs can be used to demonstrate the value of testing in quantitative terms.
Yep.
That's very important.
Yeah, yeah. Please go ahead. I will
Sure,
make my screen a little larger.
sure. If you're able to see my screen, just a minute.
There we go. Lovely. Lovely.
So what I'll show is basically I've used a simple Excel sheet in order to demonstrate this. So I actually have created an Excel sheet where I'm actually where I put in three different phases. So assuming that I'm actually doing testing in an agile mode, I'm actually having a sprint testing phase, which is where I'm actually writing doing a sprint planning. I'm reviewing my user stories. I'm actually doing sprint level testing, which can be mostly API testing as well as the testing of the actual functionalities. And then I may have a release sprint, or in some organizations, actually called a hardening sprint, where I'm actually putting in doing end-to-end testing, both from a functional standpoint as well as maybe an end-to-end workflow-based performance testing, as well as maybe a dynamic security test. That's some of the activities that can happen in a release sprint. And then finally, I push my application into production. Okay. And assuming that I'm actually don't forget, you can actually for time being, you can forget about the defect count. So if I go to this row, which is called repair hours, on an average, I'm assuming that it may take, once I actually have a defect during the sprint phase, I may actually take, or my development team might take around 2 hours to fix it. And if I'm actually somewhere towards the release testing phase, the defect fix may take a little bit more longer, and I may actually end up with maybe 8 hours of effort. And then I'm actually going to spend around maybe around 20 hours of effort once I'm actually in the production phase. That means like I'm actually pushing my build into production, and once the defect is there, then I may actually have to, the support team may actually spend time in analyzing it. It may get assigned to a developer. The entire activity may take around 20 hours of effort. And I'm assuming that your hourly rate is going to be 100 hours. That means like every hour of work is costing around $100 or £100. It's just a value. And I'm actually putting that as constant for all the three phases. Okay. Now, if I'm actually having a simple calculation of maybe I'm having one defect in production, one defect during the sprint phase, I'm actually spending around $200 to fix it. That means like I'm spending 2 hours at the rate of $100 per hour, and I'm actually having a cost of $200 to fix it. Similar to this, if I'm having a defect during the release phase, my cost of fixing the defect is going to be $800 because I'm spending 8 hours at the rate of $100 per hour. So the total cost is going to be 800. And similarly, if I have a defect in production, I may end up spending $2,000 because my total cost to repair or hours to repair that particular defect is 20 hours. So that multiplied by 100 will actually give you around $2,000 is the cost of fixing defects. So you have three numbers now, like 200, 800, and 2000, which is basically telling me like this is the cost that I'm incurring in order to fix a defect, either during the sprint phase, which is 200, or if I'm actually in the release phase, it might cost you $800, and around $2,000 when I'm actually in the production testing phase. But if you look at the ratio, you're almost spending like 10 times the cost that we are spending in the sprint testing phase when I'm fixing something in production. This is
It's
actually a good
generally
lesson.
cheaper to try and fix
Right.
bugs
So
in
the
fix
sprint,
bugs in the sprint.
yes, the sprint is what you should focus around, because that actually shows that if you're applying shift left principles, or if you're actually shifting your testing to the left, you can actually arrest or find a lot of defects within the sprint, and you can actually contain the cost. That's one thing that you're demonstrating here. But that's a larger application of this. So The same example, I'm actually using the same values, $200, $800, and $2,000 as the cost per fixing defect in terms of the repair cost. And I'm assuming that you're not actually having a testing team. Assuming that you're actually working in a model where there are no testers and there's no one is responsible for testing, and I'm incurring around 10 defects in production. So with this rate, the total cost that you're incurring to fix those 10 defects that are common in production is goes to be $20,000, because you're actually having no testers. None of the defects are actually identified in the production testing phase. And then each defect is actually going to cost you $2,000. And then your total cost of fixing is around $20,000. Okay. So this is the worst case scenario where you don't have a testing team and you're actually finding all the defects in production. Okay. Now we'll actually go one step back, where I'm assuming that I'm actually doing in my entire testing within the release, and I'm actually incurring this cost of around, because I'm again having the 10 defects coming in. But in this case, instead of $20,000, since I'm actually fixing defects before the build went into production, I'm actually having a cost of $12,000. I'll explain how you actually got this $12,000. So if 10 defects were there in production, you are actually spending around $20,000. And now, since I've actually found these defects in the release testing phase, I'm spending around $800 to fix them. So my total cost of fixing is around $8,000, and the savings that I'm getting by having a testing team here is $12,000. So instead of spending $20,000 to fix 10 defects in production, I'm able to save around $8,000, and I'm actually I'm actually saving $12,000, and I'm actually getting a better result. So
Yeah.
now,
Yeah.
assuming that you're again shifting your left testing to the left, I'm actually finding these 10 defects within my sprint. My total testing cost is, again, the savings that I'm getting is around $18,000. So instead of actually finding all the 10 defects in production, instead of having a loss of $20,000, here I'm actually able to save around $18,000, because I'm actually finding all my 10 defects in my sprint testing phase, and I'm actually only spending $2,000 instead of $20,000 to fix them, and the overall savings that I'm getting is around 18,000. So this is a good way of actually showcasing the value in terms of dollar savings to your stakeholders, which can tell me, for example, I have a release where I'm actually finding 90 defects in my sprint testing, 10 defects in my release testing, and maybe one defect has been leaked to production. So what this is telling me is, like, I'm able to bring in a savings of $172,000 on your support costs or on your fixing cost, defect fixing costs, because I'm finding defects early and I'm actually having very minimal leakage going into production, due to which I'm able to save around 172K of revenue, which is very significant. And if you add up these numbers for every sprint or every release that's happening within an organization, this will actually run into millions of dollars of savings. And very rarely I've seen testing organizations trying to actually showcase this as a metrics or a KPI to the stakeholders. So this is mostly an IT, oriented metric or testing focus kind of metrics. But if you also look at maybe something like I would say availability. So availability is one important parameter that is actually considered both from a DevOps as well as from a site reliability engineering standpoint. So SRE is very important, and applications, customers are looking at applications to be available maybe 5 nines, or with an availability percentage of 5 nines, 3 nines, or 4 nines. So that's the availability that's actually being considered by customers. So in the sense, like, I should be, if I'm actually having an application which is actually having availability percentage of 5 nines, that means in a month the application downtime is actually going to be only for 26 seconds. Okay, that's a calculation that is being applied. So that means, like, my applications are available throughout the month except for 26 seconds. And this downtime can be due to many reasons. It can be an upgrade failure, or it can be due to a bug, or it can be an hardware issue. But having said that, the total amount of percentage of time that I'm expecting my application to be available is less than, what you say, only 26 seconds. It will not be available in a month. And if I go with the calculation of maybe 3 nines, your application can be down for a maximum of around 43 to 44 minutes in a month, which actually shows that availability is low. And if I actually go with maybe 4 nines, your application can be actually be down for maybe like around 4.38 minutes per per month. But if you actually look at the cost, for example, if I'm running an organization which is actually having operations 24 bar 7, that means, like, customers are using my applications throughout the day and night. In that case, if I'm actually having a downtime of maybe 43 minutes, and if I'm actually looking at the cost of 1 minute of downtime, I've actually assigned a number of $5,600, which is basically a number given by Gartner It can be any number depending on the business that you're running. It can be a higher value or it can be a lower value. But if you look at this amount, if I'm actually having a 43-minute downtime and every minute is actually going to cost me $5,600, you're actually losing around $245,000 if I'm actually looking at an availability of 99.9%. To make it much simpler, you look at this metrics like 3 nines, 4 nines, and 5 nines as the availability percentages. What you can see is like if your availability is at 3 nines, you're actually losing around $245,000. And if you're at 4 nines, you're actually losing $25,000. And if you're actually at 5 nines, you're actually only losing around $2,500 of business every month. So this is one good metric that you can focus around, because if your application is actually having good quality, both in terms of functional as well as non-functional parameters, you're actually going to have higher availability in production. So if your application is able to scale, if you're applying good performance engineering practices, that means your application will have better availability in production. If you have tested your application well, you'll not have downtimes. Your application may not even come down in production. Or if you apply good testing practices in terms of security, so every now and then we actually see websites being attacked with denial of service kind of attacks and things like that. So we have done good security testing. That indicates that if you want to demonstrate the value, if you are not having any kind of downtime due to security issues, you can actually show it in quantitative numbers. So both these examples, what we have done here is you're actually showing a quantitative number, which will actually help the business as well as the IT stakeholders to understand the quality and the value that the testers are actually adding to the day-to-day work that's happening in an organization.
Can you stop sharing your
Yep.
screen?
Yep.
Because I think when you had screen sharing on, I was getting a double feedback of my voice. So I apologize for anyone on the recording or the live stream if my voice doubled up. It seemed to be an issue when George was sharing his screen, and I was getting both feedback from my microphone and I think feedback from George's audio. But it seems to be working now. So as long as you don't share your screen again, I think we're good. We can avoid that issue we were having.
Yep.
But that was a good showcase. In terms of one of the points on improvements to productivity, there are other elements that people could potentially focus on as well if you're trying to bring in some quality metrics. An easy one, if you've got like your CI pipelines already set up, is your build time. How long does it take to build your current application? Because if developers have got like a good practice of writing unit tests, but they get to a point where their builds now take half an hour to get through, and if they want to be able to run those tests locally, they have to sit there for half an hour, watch it pass fail before they raise a pull request or before it goes through the pipeline. So sometimes teams can get to a particular point where your builds are actually taking too long, and bringing that down can improve engineering productivity. And I think there was another focus point. Some people like to focus, I guess, on test code coverage, and that in itself is not necessarily the best metric, because if you tell someone that's what you're measuring, anyone can game that and write fake tests that don't actually test anything, but gives you code coverage. Yay! But it is like if it's one metric that you can get as a team to work towards if you want to bring up the bar of test coverage as well, potentially.
That's correct.
So next question I have. Have we mentioned any tools that we can use to help communicate the cost of testing?
Maybe I've not seen a commercial tool that actually has all of these elements. There are tools that actually gives you information around some of these IT metrics. For example, there are tools like Clara as well as IGA that can actually give you some of those IT-based metrics like change failure rates, deployment frequency, and things like that. But the best thing to look at is having a custom developed tool which might actually get you a better which will actually give you a better control on configuration as well as customization. So we can actually go with a tool like Power BI or Tableau and then create a custom report which can actually demonstrate some of these values. So if you're looking at creating a custom tool, you may need to actually have connectors that can actually connect to maybe a production ticketing tool, your DevOps tool set, your production monitoring tools, as well as other lifecycle tools that you might have. And then you might also need some custom logic, which, for example, you might need some custom code to be written in order to find out the productivity baseline. If you're actually trying to showcase business-based metrics like productivity improvement or your revenue baseline. And then you may also need to have define your cost of repair, the hours of repair, the hourly rates, and things like that. So what I've seen working rather than a commercial tool, if you want to actually demonstrate the value of testing, I would actually go with a custom tool, which is developed using a dashboarding tool like Power BI or Tableau, which can actually communicate the value of testing in a much effective way. Maybe you can actually even build a mobile front end using the Power BI mobile version, which can be very useful for stakeholders. So I'd actually go with a custom tool set rather than actually looking at a commercial tool for demonstrating the what do you call the KPIs or the metrics around cost savings or the value of testing.
I think everyone loves a pretty diagram, and
Yep.
if you can give someone a dashboard to give them insights, you make something that's intangible, like software testing or back end code. You just give something that someone can look at and go, "Oh, things are happening. I have
Yep.
more. I have more confidence in what you're telling me when you give people a pretty diagram."
Hmm.
In my previous team, I worked on a mobile analytics dashboard where we would monitor things like crashes and usability, how many times people were dropping off certain features, or how easy was it to complete certain tasks based on the percentage of people who actually got to the end. How much time people spent reading terms and conditions.
Yep.
Most people don't read terms and conditions. It's not really a very useful feature. And yeah, it was a good fun building out that dashboard and bringing up some of those metrics around quality to the team as well. And I'll put a link to my blog post on metrics and quality for people who are interested a little later. So yeah, creating your own dashboards, getting in a little bit of data analytics is a really useful skill, and everyone loves a pretty diagram.
Yep. That's true.
Um, have you ever had a manager or dealt with someone in the business who was like, I want to fire all the testers, or let's have all the devs do all the testing, or how do we get rid of this expensive manual testing?
Yep. So yeah, that's something that I've heard multiple times from what do you call, mostly coming in from organizations who do not have a testing team, or who are actually not ready to invest in a testing team. And I've also seen that in from coming that request coming in from organizations where there's heavy investment on testing and they're actually looking at cutting down the cost. But you cannot actually live in. I don't think the technology has matured to a state where you can actually eliminate testers and then get to a state where what do you call, everything happens with the click of a button. So you're a long way away. I would say another 10 to 15 years. I think it should take a minimum of 10 to 15 years in order to even remove 25% of the testers that are currently employed. So that is a long way. There's a long way to go, and I don't think so. It's the same story, Sam, like test automation. So when I started my career, there were tools like Silk Test. We actually had Rational Robot and all those tools in the market. And even now, if you look at the average automation levels across all the companies across the globe, I don't think it'll be more than 20 or 25%. So it's almost the same thing that's around, even with all these artificial intelligence, AI, ML, NLP, all of those stuff. I don't think we've reached a state where we can actually eliminate testers, nor the developers can take up testing. So look at the developers, what do you call it, life of a developer in a sprint. He hardly gets 2 to 3 weeks of time to review the user stories. You may have your own, the clarity of user stories might be poor. He may actually have to set up the environment. He may have to create the design, code, do unit testing. By the time 3 weeks are done. So unless there's an innovative method where you can actually improve the white box testing coverage or the developer testing coverage, you're still going to need testers working in a sprint. And then, for example, like I've seen some innovative tools that have actually come up in the market that can actually bring up unit test code coverage. For example, if you look at this tool called DiffBlue, which is funded by Oxford University as well. So that tool actually has intelligence to generate unit tests. So why developers are not doing testing? It's primarily because they don't have time to do it. That's the reason why they are not actually doing unit testing. So there are some innovative steps that have actually happened, which can actually improve the development, what you call test coverage, which can actually reduce the effort that testers are spending. Because if we get a better quality product from the development team, it might actually bring down the cost of testing. And the other important aspect is it's always good to actually have a third person or a third eye looking at your product and giving you feedback. And even in the testing world, also it's very popular. If you look at maybe something like crowdsourced testing, is a good example. Like you have third parties or who you're actually having something who's very new to your application giving you feedback. That adds a lot of value. So the role of a tester is actually going to be there, and the developer may not be an SME on your application functionality, nor he might be good at your domain. So you definitely need someone with functional expertise to be part of the team giving feedback. So it's impossible to remove, what do you say, testers, a role of a tester, and neither it is possible to do 100% of automation. I've not seen 100% of automation across the life cycle. It's not like you get a user story, there's a tool that actually reads the user stories and generate test cases. No, that's not there. So most of the test automation that has happened is on the execution part of it. Like where you're trying to automate the test execution part. The amount of automation that has happened on the activity that happened before test execution has not been automated fully, or there are not much of tools that can actually do maybe designing of an automation script, or there's no tool that can actually directly take a user story, define an acceptance criteria, and then generate an automation script. There is some amount of human intervention that's required. So unless that is there, 100% automation is not going to be possible. Testers can actually keep their job; they are safe for another 15 years. And then maybe the only thing that you can look at is how that I can make my life easier, how that I can actually improve the speed of testing, how is that I can actually eliminate some of the wastages that might be there within my life cycle, how is that I can actually automate a small step, maybe like data provisioning, a simple example. Can I make it more, what you call, self-service kind of model? So there are certain things that testers also should think through, so that the cost of testing can be brought down. So it cannot be eliminated as such.
Now where are we with I think that seems to be at a really good point to try and close things off, because we've got another 5 minutes.
Yep.
So if someone just started their testing career today, or they're fairly new to the field, what would be your one insight from your extensive 20-year career, or your one tip that you'd want them to walk away with?
Okay, so maybe it also applies to people who have been doing functional testing, or what do you say, the manual mode of testing as well. So there are a lot of, first of all, one needs to decide on what he or she wants to do. Maybe at least it's good to have a 3 to 5 year career plan. So there's a feeling that test automation is the only thing that you can do around testing. No, that's not true. Test automation, there's a big demand for test automation, but there are other career streams that are actually possible within testing. For example, data testing. So data testing, I would actually consider test data management and anything to do with data warehousing, big data, all of those, or BI tool testing, all of those, BI report testing, all of those comes under data testing. So test automation is definitely an area where you can focus on, but test data or data testing itself is actually a huge opportunity area. And there's a lot of focus around package applications. If you look at maybe SAP, salesforce.com, there's a huge opportunity that you might find around package application testing. If you're an expert in an area like supply chain, or you're actually good at maybe retail, so it might be a good area where you can actually move maybe you can shift your career from a domain expert to maybe a functional SME around some of these package applications. Look at cybersecurity or DevSecOps as an area. Like there are a lot of security threats happening for every organization. There's a heavy investment going around security. So application security testing, DevSecOps is another stream of work that you can actually look at. And then the final area that you can look at is maybe non-functional testing. Primarily, performance engineering is a good stream. Applications moving into cloud, you are always focused around what do you call digitizing your applications. So performance engineering continues to be, what do you say, a good area to focus on. You don't require a lot of programming expertise, but still limited amount of programming expertise, a lot of analytical skills, a lot of planning skills. And then one of the emerging areas which I would actually club along with performance engineering is chaos engineering. Lot of demand is there for chaos engineering. You can see a lot of innovative tools that have come into the market, like Gremlin. It's actually something, if you have some cloud background, if you're good at maybe Azure, Amazon Cloud, or Google Cloud, that's definitely one area where you can actually learn uh, the techniques around chaos engineering, how to run tests, how to make your system more resilient. That is the one more area where you can actually, what do you call, excel. There are 5 or 6 streams that you can decide on. Some of them requires programming expertise. For example, test automation, definitely you need some kind of programming background, or that's something that you can learn within 3 or 4 weeks. It's not something that is very tough to learn. The only thing that you need to have is basically you need to actually have some common skills. Communication is very important. You need to actually have the knowledge around agile and DevOps principles. You should know the agile ways of working. So these are some of the fundamental, or the, what do you call, the primary skill set that you might need in order to actually, get a good career, or to actually have a good career in the software testing scene. And people are already in this stream. If you're actually just doing manual mode of testing, I think the first thing that you need to have is a mindset change. That if you want to survive, you need to actually learn some of these things. You should actually pick one of these career streams. You should actually focus around learning, and then you should be also open to learning new technologies. So there are some maybe tertiary kind of skills that might be required. For example, like things like knowledge around cloud, basics of AI machine learning, what do you call, knowing some of these practice around analytics. So there are some skills that you need to acquire as well on top of the primary and the secondary skills. But it's very important to stay relevant.
Yeah, I wanted to counter that. Often performance testing is called non-functional testing, and I
Yep.
would actually say that performance has to be functional. Have you ever? I mean, like, have you ever been to a website and it's taken 5 to 10 seconds to load? Did you
Yep.
want to buy something from that? Did you want to
No,
give
no.
that website your credit card details?
Yes, yes, that's true. That's true. It's something that catches attention very well. And you want, as a customer, I won't be actually classifying defects or issues against non-functional or functional,
Yeah.
because for me the application did not function. That's the only thing that I'm bothered about.
Yeah, exactly. As an end user, if a
Yep.
website takes 5 or 10 seconds to load, you're basically, this website's not working.
Yes.
I'm not gonna buy anything from you.
Yes. That's true.
So it'd be nice to see the industry stop talking about performance testing as a non-functional requirement, because I think it's
Yep.
core to business.
Yep.
I'll just give a brief overview about chaos engineering for anyone who's
Yep.
unaware of the term. So if you're deploying things to a cloud service like AWS, you often have like clusters of servers all over the world, and your code can be deployed almost anywhere. One of the first approaches to chaos engineering is like, what happens if I bring down a cluster or a service or a region? What happens to my service if things fall down? And the thing is, you don't want your customers to discover when or how things can crash and fall down, but you also want to be able to test how your system can recover in emergency situations, or if things go down, which is, we'd like to think that our technology is bulletproof, but it is hardly bulletproof, and things fail all the time. People think it is chaotic and ad hoc testing, but it's actually about trying to discover where your system is not as resilient as you thought it would be, and so you can improve the resiliency such that when those failures do occur outside of controlled situations, your systems can recover more effectively. And it is a really interesting field of introducing elements of quality in those processes. So thank you so much for your conversations today. We're just on time with an hour. I will share this gorgeous mind map of all the discussion points we've had today with everyone. And I hope you all have a stay safe, and enjoy the rest of your day. Thank you.
Thank you, Sam. Have a good